What is up, math superstars? In this edition of Mr. Peterson Presents, we are in part number 2 for our geometry section. We are talking about this big word right here called quadrilaterals. So in your notes, what we have is we have a column for your shape, we have a column for the name, and we have a column for the description. And so this will match your notes so you can follow right along here and fill in the goodness that is quadrilaterals. So our first one, we're just figuring out what this word quadrilateral means is your first shape. In your description, what we have, this is a polygon that has 4 sides. So when we talk about polygons, this is any sided shape. And any shape that has 4 sides to it, we call those quadrilaterals. So that's your first description. And for the second part, all the angles, when you add them all together, so if we labeled any one of these quadrilaterals here, so say if I focused on this one right here, the one that I circled, so if I have angle 1, angle 2, angle 3, angle 4, when I add all those together, they're going to equal 360 degrees. So now what we're going to do is we're going to talk about some specific types of quadrilaterals. The first one we have is a trapezoid. So in our trapezoid, this is a quadrilateral because it has 4 sides, and it has exactly one pair of parallel sides. So it's very important to get the specifics down in here. So please don't abbreviate and rush through your notes page, please. So what you have here in the quadrilateral, the one pair that's parallel sides, the top and the bottom, if we want to call this a trapezoid, these would be parallel. So now we have a quadrilateral called a kite. And so in your description, this is a quadrilateral, has 4 sides. And then here in our second description, it has 2 pairs of adjacent and congruent sides. So here's what this means. It means that the 2 shorter sides, these are congruent to each other. So I put 1 hatch mark there. And then the bottom 2, these are congruent to each other. So I'm putting 2 hatch marks. And so adjacent means they're next to each other. And then it also has 1 pair of opposite congruent angles. And so we could say that these 2 angles right here that I labeled are congruent. Now I have a parallelogram. So what the shape is, it's a quadrilateral because it has 4 sides. The opposite sides are congruent. And so we can say that the top and the bottom are exactly the same size. And we have the right side and the left side are exactly the same size. So we have 2 pairs of opposite congruent sides. The opposite angles are congruent. And so we can match these up. This bottom left angle matches up with the top right angle. And we can say the same thing for the bottom right angle matches up with the top left angle. And so you see how I marked those with the little arcs in the corner. And then last but not least, we can say that the opposite sides are parallel. And so just like we did, the top and the bottom are congruent, the top and the bottom are also parallel. And we can say the same thing with the left and the right. So I'm going to label these with either 1 arrow or 2 arrows. So now we have a rhombus. So with a rhombus, this is a parallelogram, but has this very unique characteristic that all the sides are congruent. So we label all of our sides with 1 hatch mark all the way around. We can say that the opposite sides, just like a parallelogram, are parallel. So we label that with our arrows. So we do 1 at the top and the bottom, and then we're going to do 2 on the left and the right. And then we have our diagonals. So our diagonals, they bisect each other, which means that they cut each other in half, and they're going to intersect at right angles. And so the way this looks here, if I'm going to draw in my diagonals here, So when I draw in my diagonals, they bisect each other, and in the middle right here, that when they intersect, they're intersecting at right angles. So now I have a rectangle. Rectangle is another type of parallelogram, but this time all the angles in every corner are 90 degrees, and so we put the little square in the corner signifying that is 90 degrees. We have our opposite sides are congruent, so the top and bottom are congruent, and the right and the left are congruent with each other. We can say that the top and the bottom are parallel. Same thing with the left and the right. And this time the diagonals are the same length, and they bisect each other. And so if I was going to draw in our diagonals, so I can say that these diagonals are going to be the same exact length, and they just cut each other in half. So now I have a square. The square is the last of is a very specific parallelogram. In this parallelogram, all the sides are congruent, just like a rhombus. Each angle is 90 degrees, just like a rectangle. And our diagonals here, diagonals are perpendicular, meaning that when they intersect, they're going to make 90-degree angles in the middle. And the last feature is not listed here is that the top and the bottom are parallel, and the left side and the right side are parallel to each other. So when we talk about squares, we can say that a square is always a rectangle because it has all the same features. We can say that the square is always a rhombus. We can say that the square is always a parallelogram and always a quadrilateral. So when we talk about sometimes and always, I kind of hinted at it with the last slide, but here we have our little lovely family tree of quadrilaterals. And so in order to get started, we're going to start right here at the top with a quadrilateral. If it has 4 sides, it is somewhere in the family. And so what's going to happen is if we're looking down, so say if we go down apart in the family tree, we're going to use the keyword sometimes. And so I can say that my quadrilateral is sometimes a trapezoid. It is sometimes a kite. And a quadrilateral is sometimes a parallelogram. And then inside the parallelogram, it kind of branches off a little bit. So anytime that we can follow the arrows down, it's going to be sometimes. Another key phrase that we're going to say, if we go up, is going to be always. So the way that this works is I can say that a square is always a rhombus. I can say that a rhombus is always a parallelogram. But I can say that a square is always a parallelogram because I'm going up in the chart. You might want to make special note of that. But a square is always a rectangle, always a parallelogram. I can say that a parallelogram is always a quadrilateral. I can say that a kite is always a quadrilateral, and a trapezoid is always a quadrilateral. And then there's another last keyword is never. And so when we say that it is never, we can say that a trapezoid is never going to be a kite. A kite can never be a rhombus, and so we got to keep it within those little family trees here. So we're keeping it all together when we talk about never. And so parallelogram can never be a kite. Parallelogram can never be a trapezoid, because when we talk about the features, they're going to cross out of each other eventually. And the last little part here is we're going to find the missing angle. So the way we're going to do this is we know that all the angle measurements in a quadrilateral If I was going to add up all 4 angles, they're going to equal 360 degrees. So the way to find the missing angle, which is x, the first step is I'm going to add up the 3 angles that I know. So I'm going to add up 110, 92, and 88. So when I add these together, I'm doing some math here because I don't have my calculator. 10, 18, 19, carry 1. We have 290 degrees for 3 angles. This would work. This would be okay if we're dealing with triangles, but I have quadrilaterals and I have to find the x. So the second step is I can take 360 and I'm going to subtract it from 290 to find my missing angle. So I can say that my missing angle, when I subtract this, comes out to 70 degrees. And I can go ahead and double check that math. If I put in 290 plus 70, it should give me 360 degrees. And so the steps to find the missing angle again are you're going to add up the 3 angles that you know. You're going to subtract it from 360 to get your missing angle.